My interest has always been more about understanding the world that I live in. And if you keep asking why enough times, then you get to the biggest questions in my case. And that's, why are we here? Why is the universe the way it is? Why is it evolving the way it is? Why? So the three main components of the universe is regular matter like you and I and galaxies. And that actually only constitutes barely 5%. And then the rest of it is made of dark matter, which is a type of matter that interacts only through gravity, which means it doesn't emit light, we can't see it. And that represents about 27% of the total matter content of the universe. And then the rest of it is dark energy, and that's about 68% of the universe. So dark energy is the thing responsible for the accelerated expansion of the universe. We've known that the universe has been in cosmic expansion for as long as it's been a thing. Now, this expansion is accelerating, and we were expecting that through gravity. Gravity pulls things together, so we would expect that the expansion would slow down. And the fact that it's actually not slowing down but going faster and faster and faster means that there is something that is driving, that is counteracting the gravitational effects that we were expecting. And that's what we know about it, and we needed to give it a name, and we called it dark energy. We have only one point of view on the universe because all of our observations are done from the edge of a galaxy like this one. So this one is not ours, but it's one very much like ours. And this is only one in a billion of similar galaxies in our corner of the universe. And so really, we're drowned in a sea of vastness. And then the question is, well, would things look differently if we were somewhere else?
Once there are people on Mars and an ongoing market for transportation of people between Earth and Mars, it will create what does not currently exist, which is a strong economic forcing function for the rapid improvement of propulsion technology.
The distance between Earth and the Moon, it's a 4-day trip. The distance between Earth and Mars, 9-month trip. Distance between Earth and the next star, hundreds of thousands of years. So we're just not going to be there with any conventional rocketry.
If you want to do like deep space propulsion for humans, you're going to need antimatter rockets. So we need to figure out how to make antimatter.
And that's relatively nascent physics, especially in terms of containing antimatter, because if antimatter comes in contact with regular matter, it just turns into light and vanishes. And so you got to figure out a magnetic field basically to hold the antimatter without it touching anything else, including the photons in the magnetic field. So it's a very tricky problem.
If you can figure out how to do like an afterburner with reheating, you can achieve like 100 kilometers a second of delta V, which means you could fly a Starship single stage to Pluto and back in like less than a year, which would be pretty cool. And even with just the dumbest antimatter engine you can possibly imagine, like just the simplest possible thing. Gravity is an unusual force. Space-time is warped by mass and by energy. And there are certain ways of warping space-time that if you could warp them in that way would have the effect of essentially creating a bubble of space-time that you're able to translate through space much, much faster than the speed of light. So it's like essentially warp drive. This was most famously invented by Alcubierre as a physicist who was inspired by Star Trek to figure out what shape of space-time would allow you to do this. Once you figured out that shape, well, that's pretty straightforward. It's just doing some math. You have to figure out, okay, how do I actually bend space to make this shape? How do I create a matter distribution that can do this? And it turns out that all the really fun stuff in space, like warp drive, wormholes, time travel, black hole traversal, et cetera, require negative curvature. So they require you to find some way to make negative mass or negative pressure matter or something very, very exotic like that. And unfortunately, we as a species really don't even have the first idea how to go and do that, except that it almost certainly will require a lot of energy. It's unfortunate, but there's no shortage of interesting places for us to explore in the solar system this generation, and maybe we leave traveling to the stars to next generation.